Today is December 5th, 2022. This is my 153rd episode for C++ 17 2023 CUDA SYCL OpenCL TBB Vulkan. I am starting a new mini-series CUDA SYCL 01 Intel Arc Graphics SYCL Reference Materials Parameterized Derivatives Adaptive Quadrature. I'm discussing a lot of things in this episode. I filmed this video for my own reference in future. To install Intel Arc A-series graphics, I would highly recommend you to refer to these links. Intel Arc A-series graphics desktop quick start guide. We have to carefully read this documentation. Supported hardware configuration. Resizable BAR or Smart Access Memory must be enabled for optimal performance in all applications using Intel Arc A-series graphics. Platforms supported are listed below. Support for more platforms will be added at a later time. As of today, Intel 13th generation core processors, 12th generation Intel core processors, 11th generation Intel Core processors, 10th generation Intel Core processors, AMD Ryzen 7000 series processors, AMD Ryzen 5000 series processors. These processors are supporting resizable BAR or Smart Access Memory. Otherwise, we may not be able to use full performance of Arc A-series graphics. Sadly, my GPU device is 9th generation. This GPU does not support resizable BAR or Smart Access Memory. Also, you can read more about Resizable BAR Support On from this link. This website also explains how to update GPU BIOS for NVIDIA graphic card, how to update motherboard to support resizable BAR. So this document should be carefully read if we want to support resizable BAR support. I would also recommend you this link. In this link, you can read more about resizable BAR support. What is resizable BAR? Reading this documentation is very important if you want to support resizable BAR performance improvements. C++ 11 introduced Lambda for the first time in C++ language. As of today, in C++ 20 standard, recursive Lambda is not yet supported, but in C++ 23 standards, recursive Lambda will be supported through deducing this. Likewise, SYCL as of today does not yet support recursive kernel, but CUDA supports recursive kernel. So I am very positive that SYCL will eventually support recursive kernel 2 in the future. So I finally ordered this graphic device, Intel Arc A770 limited edition 16 GB. If you scroll down, you can find Intel oneAPI reference materials, data parallel C++. You can download the PDF book for data parallel C++ or purchase a hard copy of this book. From this link, you can download data parallel C++ book source samples. I would highly recommend you to read oneAPI programming guide by clicking this link. From this web page, you can download as a PDF Intel oneAPI programming guide. Also, Intel oneAPI DPC++ C++ compiler developer guide and reference. From this link, you can download oneAPI DPC++ compiler developer guide and reference by clicking this link. Also, oneAPI GPU optimization guide. This link is also very useful. oneAPI GPU optimization guide. You can double-click this link to download the GPU optimization. If you are using 8th generation Intel processor graphics, you can double-click this link and download this PDF. If you are using 9th generation Intel processor graphics, you can double-click this link and download this PDF. These materials are very useful to understand modern graphic device. I started Visual Studio Code CPP 17 2023 parallel. Select empty space. Click this button 153 Parameterized derivative. Click this button para.cpp. Hit enter. Ctrl B. I will copy and paste these links for my future reference. Ctrl click. In this video, they explain how to solve derivative dz over dt using chain rule given like this. This is our problem. Z is a function of x and y, where x is sine 2t, y is cosine t. We want to evaluate dz over dt when t is 0. In Visual Studio Code, include CPG, SCD, extensions, include CPG, calculus, namespace, CNA, CPG, numerical analysis, namespace, CPT, CPG, types, void test, parameterized, derivatives. In the main, copy this function, paste it here. We need to introduce using namespace, CPG, numerical analysis, then comments. We define auto G. G is a function of x and y. Semicolon. Return x times y plus 3.0 times x times SCD power y 4. So we defined function z over x and y, two variables. Here auto x, auto t, semicolon, return SCD sine 2 times t, auto y, auto t, return SCD cosine t. So z is a function of two variables, x and y, defined like this. Then x is a function of t, y is a function of t, defined like this, respectively. Don't miss semicolon. How can we evaluate dz over dt. How can we evaluate dz over dt? There are two approaches. First, dz over dt can be represented dz over dx times dx over dt plus dz over dy times dy over dt. This is so-called chain rule. There is another approach. We use mathematical definition. That is, dz over dt can be computed directly. Or dz over dt chain rule. We capture all as reference, then all t. Now all dx over dt can be computed. CNA, we can use 5-point stencil or 7-point stencil or 9-point stencil. I will simply use 7-point stencil. It doesn't matter. We are differentiating first order derivative function x, because this is dx over dt, where t is 0. Derivative of x at t equals 0. Or dy over dt CNA 7-point stencil first order derivative y with respect to t. T is 0. I say first order derivative. This one represents first order derivative. First order derivative of y. In this case, we are using 7-point stencil. We can use 5-point stencil too. Now, we need to create command dx cna create command d 0 1 or command dy cna create command d 1 1. Please note that D01 is defined in this file. If you scroll down, you can find D01, 01. It means we differentiate with the first variable. In case of D11, we differentiate first order derivative with respect to second variable. Once again, in this case, D01, we differentiate first order derivative with respect to zeroth variable. So, zeroth variable in this function represent x. This is 0, this is 1. Now, or dz over dx. This is a partial derivative. CNA partial derivative. We pass cmd dx. Then we differentiate function z. We have to pass two values because function z takes value of x and the value of y. X itself is function of t. So here we pass x, the value of x. The t is determined here. So t, y, t. We differentiated dz with respect to x. This is a partial derivative. Copy, paste. Now dz over dy, command dy, the remainder is the same. Now we return this chain rule. So dz dx times dx dt plus dz dy times dy dt. This is chain rule. Don't miss semicolon. I say oral n represent numerical evaluation. dz dt chain rule. We call this function by passing the value of t. T is 0. SDD cout using chain rule. We print out this value cpz and there. Now we can use any compiler. I'll be using Clang compiler 153 Parameterized derivatives. Clang++ SED C++20 para.cpp ltbb12 or c.exe. Hit enter. Wow, it built without error. I will copy this command string for your reference. Now cls c using chain rule. The result is 6. Control home. If you control click, the result is 6. So our computation is correct. Control end. This is very silly. Okay, we used chain rule. This is very silly. Instead of doing this, we can use mathematical definition. That is dz over dt. Now here auto dz over dt using definition. We capture as L value reference. Then auto t, don't miss semicolon. Here auto z over t. We capture as reference auto t. Now we return z is a function of x and y. So we pass the value of x, the value of y, then return. don't miss semicolon. Then return CNA. We can use 5-point stencil algorithm or 7-point stencil algorithm or 9-point stencil algorithm. It doesn't matter. We differentiate first order derivative. Then we pass z of t. This function takes the value of t. Okay, don't get confused this t with this t. If it is confusing, you can change it to tt, tt, tt. Okay, now we copy, paste. This is definition. We are using mathematical definition and call this function. Copy, paste using math definition. We build again. CLSC. Of course, the results should be identical. Which one is simpler and more efficient? When we use mathematical definition for dz over dt, we differentiate only once. When we use chain rule, we have to differentiate 4 times dz over dx, dx over dt, dz over dy, dy over dt. If we use chain rule, we have to differentiate 4 times. When we use mathematical definition, we differentiate only once. Of course, this is not only more compact, but also gives better result. If you change your mindset as to see the mathematical definition, your mathematical problem becomes very compact and accurate. For example, I implemented 7-point stencil algorithm here. In this case, our function takes a single variable. Using mathematical definition, I implemented partial derivative. In this case, partial derivative, I fix variable other than VAR indexed variable. Other than this variable, I fix all other variables. Then I apply 5-point stencil algorithm. I strictly applied mathematical definition for partial derivative. Now we can solve any derivatives, first order, second order, single variable, 2 variable, 3 variable, any number of variables. Most of us are familiar with algebraic approach to our mathematical problems, such as chain rule or some other stupid mathematical theorems. These are useful for algebraic approach, but for numerical solutions, mathematical definition play the critical role. For example, I is integral for single variable. If we apply mathematical definition, we can easily implement multiple integrals very compactly, simply and easily. Because if we are going to integrate f xy dx, then integrate with respect to dy, this is obviously double integral. But if we find like this, this is inner integral. In this integration, x is the variable of integration, so y should be fixed. Then we can say fx with y fixed. Then this problem becomes f of x. Then we are integrating f of x with respect to x. In this case, y is fixed. This is our single variable integration. So inner integral becomes a function of y. Okay? Now, this becomes into inner integral y dy. This is again single variable integration. We solved the problem of double integral using single variable integration. I strictly applied mathematical definition. Here I made a simple mistake. It should be t because the value of t can be changed. I will build once again CLSC of course. Now we will learn adaptive quadrature. In this video, I highly recommend you to watch this video about adaptive quadrature. We will be using this algorithm to implement numerical integration.